Good day everyone. Today I will be discussing the first type of variation, which is the direct variation. When we say direct variation, it is a relationship between two variables, x and y, that can be written as y is equal to kx, wherein your k must not be equal to 0. And remember also that in our equation, y is equal to kx, k here is the constant of variation that relates to variables. Let's take the first example. Let's say k is equal to 2, and let us solve for the value of y given the x, which is 1, 2, and 3. So the first thing that we need to do here is to substitute for the values of k, which is 2, in our equation, y is equal to kx. Okay, let's compute for the first one. Y is equal to, k here is 2, so substitute for the value of k, which is 2, times, what is your x? 1. Then perform the calculation. Our y here is 2. So let us put on our table. Next, y is equal to 2 times your x is 2. And then 4 is your y. Third, y is equal to 2 times 3. Your y now is 6. So let us write on our table. So if you can analyze, when your x increases, your y also increases. As we solve for the value of y, we can also use this formula to get the value of our constant. K is equal to y over x. If our y is 2, divided to our x, our constant will be 2. Same with if our y is 4, divided by 2, then still our k is 2. And then, if we substitute 6 here in our y, divide it into 3, still our constant is 2. Next, let us translate each statement into an equation. Use k for the constant of variation. So let us answer number 1. C varies directly as B. C varies directly as B. This will now be the equation. C varies directly as B. K here is our constant of variation. Number 2. M is directly proportional to N. So the answer is M is equal to Kn. That is the equation for number 2. And third, A is directly proportional to the square of S. So copying the letter A is directly proportional to the square of S. Your constant is K and then the square of your S. So those are the answers for numbers 1, 2, and 3 as we translate each statement into an equation, and we also use K for the constant of variation. How about number 4? Given that y varies directly as x, find the constant of variation if y is equal to 24 and x is equal to 3. The first thing that we need to do is to write the equation of direct variation, which is y is equal to kx. We are looking for the value of k because we need to find the constant of variation. Now we will just substitute for the value of our y, which is 24, and the value of our x, which is 3, in this equation. So we have 24 is equal to k, and then your x given 3. Let us perform the calculation. 24 is equal to 3K. And for us to cancel 3 on the right side of the equation, we will divide both sides by 3. (24) divided by 3 is 8. So the value of our constant of variation, or K, is equal to 8. This is now our final answer. Let us recall, when we say direct variation, we have 3 statements that will serve as a clue whenever we solve a problem. The statements will be y varies directly as x. It can also be y varies directly proportional to x, or it can be y is proportional to x. So remember, class, that for 2 quantities, x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. I also prepared other examples. Let's solve for number 1. We will write the equation for the given variation using K as the constant of variation. So number 1, the answer is x is equal to ky. X is directly proportional to y. Number 2, the height h varies directly proportional to weight w. We have h is equal to kw. Height varies directly proportional to weight. Third, the fare of a passenger varies directly as the distance of his acceleration. So fare, we have F, directly proportional to the distance, which is your acceleration A. So this is now our equation for the given variation using K as our constant of variation. How about number 4? If y varies directly as x and y is equal to 20 and x is equal to 5, find the constant of variation. Just like our previous example, the first thing that we need to do is to write the equation of the direct variation, which is y is equal to kx. Then substitute for the value of y, which is 20. K will remain because that is what we are looking for, the constant of variation, and our x is given, which is 5. Next, to eliminate 5, we will divide 5 both sides. Cancel. So our k now, or the constant of variation, is 20 divided by 5 is 4. This is now the constant of variation given our y, which is 20, and our x is equal to 5. Next, number 5. If y varies directly as x and y is equal to 12, when x is equal to 4, find y when x is equal to 20. Again, we need to write the equation, which is y is equal to kx. Next, substitute for the value of our y and x. Our y here is 12, and then our x is 4. So divide both sides by 4. 12 divided by 4 is 3. So our constant of variation is 3. Next, we need also to find y when x is 20. We will substitute 20 in our equation y is equal to kx, same with the value of our k, which is 3. So rewrite again the equation here, y is equal to kx. Since we are looking for y, then y will remain on the left side. K is 3, substitute. And then substitute also for the value of x given 20. Then perform the calculation. 3 times 20 is 60. So our y here is 60. Next example. If y varies directly as x and y is equal to negative 18, when x is equal to 9, find y when x is equal to 7. Again, substitute for the values of your y and x. But before that, you need to write for the equation of the direct variation. We have y is equal to kx. Your y is negative 18. And then is equal to k, and then x is 9. So divide both sides by 9. Negative 18 divided by 9 is negative 2. This is now your k. We are also looking again for y when x is equal to 7. Rewrite the equation y is equal to kx. Y is equal to, your k is negative 2, so substitute. And then your x is positive 7. Substitute again. Then compute negative 2 times positive 7 is negative 14. This is now your answer. Okay, let's proceed with the last but not the least example. The pressure P at the bottom of a swimming pool varies directly as the depth D of the water. If the pressure is 125 Pascal, when water is 2 meters deep, we need to find the pressure when it is 4 meters deep. Alright, so first we need to write the equation pressure, and pressure stands for capital P here. P is equal to, our constant of variation is represented by the variable k, and then the depth is represented by small letter d. This will be our equation. Next, substitute for the value of pressure, which is 125. So we will write there 125 is equal to K, and then your D or your depth here is also given, which is 2 meters deep. So 2, divide both sides by 2. So our K here is, you can write 125 over 2, or the decimal value will be 62.5. This is now our constant of variation. Now, from the problem, we are also looking for the pressure when it is 4 meters deep. Again, rewrite the equation. P is equal to KD. Now, substitute for the value of our K, which is 62.5 here, and our D is 4 meters. So, P is equal to 62.5 times 4. Okay, let's compute. 62.5 times 4 is equal to 250, and do not forget the unit pascals. So this is now our final answers. I hope you understand our lesson for today about direct variation. Thank you and God bless.